Okay, so let's go over the last two topics, which is 4.3 systems and 4.4, which is kind of putting it all together. So we have two choices for solving systems. We have substitution, okay, and elimination. And actually, we have graphical as well. Okay, and so we'll reference that one a little bit. We have graphing. Now, when I do substitution, you're looking to find an easy way to combine equations. Okay, this is the format we are most familiar with, equations. So y equals x plus 2, y equals x squared plus 2x plus 1, and right, okay. So in class we were, okay, substitute, and right, I would put it into this one. And as I do that, I'm left with a combined quadratic equation, which is good. I can solve for that. Now, the next type is elimination, and this is where you look for like terms. Okay, you have to have the like terms so that you can eliminate all of one variable. Okay, so that would be x squared and x, or y and y squared. Okay, but you've got to have the like terms available to match them up. Now, it's important that the resulting, right, our first step is to like combine the equations. It's important that the resulting equation has only one variable. That way you can actually solve, and then you can go back and find the points. Okay, find the points. Now, okay, so this is the general review. Now, right now, in terms of substitution and elimination, the graph is used to check your points. All right, so I'm going to clear the screen, and we're going to talk about kind of the extension knowledge of the graphing. Okay, this is the other stuff, and we're going to talk about analyzing the graph. And so the first thing I'm going to do is I'm going to look at a parabola, dot, 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 okay? And I'm going to make it concave up. Now, this is the whole equation, right? And I'm going to look at the equation of a line, okay? Y equals x plus k. And we talked about different types of solutions. Tangent, which is touching in one point, okay? So let's just say this is k equals, we're just going to say 2, okay? This creates a tangent solution because it touches once. Now, if I were to shift this graph up, okay, I'm going to change the color here. Let's make it k is more than 2. That would shift the line up. And I would get 2 single solutions. There it is, 2 single solutions. Now let's say I'm being really fancy. What if I shift the line down? Notice that's just a y-intercept less than 2 here. Okay, that would be no real solutions. That's no intersections for y equals x plus k. And this is a visual understanding. So notice if you can graph the parabola, you can try to shift the line appropriately to get the responsive or the corresponding solutions. Now, we also talked about how to do this algebraically. Okay, this means your combined equation, right? First, you have to substitute or eliminate. Your combined equation would have a discriminant that is more than 0. That's how you get 2 single solutions. What if your discriminant is 0? That's how you get a repeated solution. That's that same factor twice. Or your perfect square trinomial. But what if your discriminant is less than 0? That's how you get imaginary or no real solutions. Now, keep in mind that you have to get that combined equation first to figure out how to make that happen. Okay, so this is looking at the combination of graphing and algebra here. So I'm going to clear it and ask you one more question. Okay, whoop, let's make that blue. If I give you a predetermined parabola, and so in this case, a x minus h squared plus k, could you graph another parabola that has 2 solutions? Okay, something like this. Now notice that I am sharing the axis of symmetry. You get to pick the opening and the stretch and the y value of the vertex, okay? So let's say I do something like this. Could you describe to me the b and the d values necessary? So it looks like I need to make it narrower. And it looks like I need the vertex to be, yes, to be below. So how do I do that? Okay, how do you make something narrower? You make B more than A. That's how you make it narrower. How do you make the vertex go down? You make D less than K. Yeah, it could be negative, right? Because in this particular example, A is positive, okay? And K is positive. And so this is the general idea of how you can transform graphs into certain number of intersections. There are a lot of choices here where you could say or D is less than 0. Yes, this describes more possibilities. This is one of the possibilities. I could also make right, this is where you start thinking, you're like, oh, I could just open this thing down. Okay, so what if I just make my B value negative and I say that my vertex is higher than the one I started with? So there's lots of different choices that you can describe here. That is the last thing I would say about systems graphically and determining some unknown values.